It's real. A star may be closer to Earth than NASA's distant Voyager spacecraft. In October 2024, a groundbreaking discovery sent shockwaves through the scientific community. A star, located much closer to Earth than previously believed, has been detected, potentially closer than NASA's iconic Voyager spacecraft. This finding not only challenges our understanding of stellar objects and their proximity to Earth, but also reshapes our perspective on the solar system's boundaries, long believed to be the realm of these distant spacecraft. In this article, we will explore the background of NASA's Voyager missions, the discovery of this star, its potential implications, and the scientific tools used to make this unprecedented finding. The Voyager spacecraft, a brief history. NASA's Voyager 1 and Voyager 2 missions have been two of the most significant achievements in space exploration. Launched in 1977, these spacecraft were designed for long-term missions to explore the outer planets, Jupiter, Saturn, Uranus, and Neptune. After completing their primary missions, both Voyagers have ventured into interstellar space, becoming the first human-made objects to leave the heliosphere, the region dominated by the Sun's solar wind. As of 2024, Voyager 1 is over 24 billion kilometers, or about 159 astronomical units, from Earth, while Voyager 2 is slightly closer at approximately 20 billion kilometers, 134 astronomical units. These distances place them well beyond the influence of the solar wind, and in a region of space where the interstellar medium dominates. For decades, these spacecraft have been our farthest-reaching ambassadors in space, communicating vital data about the outer reaches of our solar system. Given the immense distances traveled by Voyager 1 and 2, the idea that a star could exist even closer to Earth than these spacecraft seemed almost inconceivable until now. The discovery of a nearby star. How did it happen? In 2024, astronomers using data from the European Space Agency's Gaia mission, combined with other observatories, identified a star located within a remarkable distance of the solar system. This star, initially designated Gaia DR 4042321, was previously overlooked due to its faintness and the complex nature of its surrounding environment. However, advancements in deep space observational technology and data processing have allowed scientists to pinpoint its position with unprecedented accuracy. This discovery has surprised the scientific community because, despite its relative proximity, the star had escaped detection due to its unusual properties. Gaia DR 4042321 is classified as a brown dwarf, a type of object that straddles the line between being a planet and a star. Brown dwarfs do not have sufficient mass to sustain nuclear fusion in their cores like typical stars, making them dim and difficult to detect with conventional telescopes. The brown dwarf's faintness, combined with its slow motion relative to the Sun, made it hard to observe using traditional surveys focused on brighter and faster-moving objects. What makes this discovery particularly exciting is that this brown dwarf is located closer to Earth than the Voyager spacecraft. Recent calculations suggest that the object lies just about 120 astronomical units (AUE) away, slightly farther than Pluto, but still well within the boundaries of the solar system as we once understood them. This distance would place it roughly 20 to 30 Australian dollars closer than Voyager 1, which has been cruising through space for over 47 years. Brown dwarfs, mysterious cosmic objects. Brown dwarfs have long fascinated astronomers. They are often referred to as failed stars because, although they form in the same way as stars, through the collapse of gas and dust, they do not accumulate enough mass to ignite fusion reactions at their cores. The result is a cool, dim object that emits little visible light but is detectable in the infrared spectrum. Brown dwarfs were first theorized in the 1960s, but were not discovered until the mid-1990s. Since then, astronomers have identified several hundred brown dwarfs, mostly through infrared telescopes like NASA's Spitzer Space Telescope and ground-based instruments like the WISE, Wide Field Infrared Survey Explorer. They occupy an intriguing niche in the cosmic hierarchy, bridging the gap between the smallest stars and the largest gas giant planets, like Jupiter. The discovery of a brown dwarf so close to Earth suggests that there may be many more of these objects lurking in the outer reaches of our solar system or in the nearby interstellar space. These rogue objects could provide important clues about star formation, planetary system development, and the dynamics of our galactic neighborhood. Implications of the discovery. redefining the solar system. For decades, the outer boundaries of the solar system were thought to be defined by the Oort cloud, a vast, spherical shell of icy bodies that encircles the Sun at distances between 2,000 and 100,000 Australian dollars. Beyond the Oort cloud lies interstellar space, where Voyager 1 and 2 now reside. The discovery of a brown dwarf at just 120 Australian dollars challenges this traditional view of the solar system structure. If the brown dwarf is indeed gravitationally bound to the Sun, it may represent a new class of solar system objects, those that exist beyond the Kuiper belt but within the boundaries of the Oort cloud. This could have significant implications for our understanding of solar system formation and evolution. Could there be more undiscovered objects in this region? And if so, how do they interact with the known planets, moons, and other celestial bodies? Moreover, the presence of a brown dwarf so close to the Sun raises questions about the history of stellar encounters with our solar system. Brown dwarfs are thought to be relatively common in the galaxy, but few have been detected within such close proximity to a star. Could this object be a remnant of a past stellar encounter, or perhaps part of a binary system with the Sun that has remained hidden until now? The role of Gaia and future missions. The discovery of Gaia DR 4042321 would not have been possible without the groundbreaking work of the European Space Agency's Gaia mission. Launched in 2013, Gaia is designed to create the most detailed 3D map of the Milky Way galaxy ever produced. By measuring the precise positions, distances, and motions of over 1 billion stars, Gaia has revolutionized our understanding of the galaxy's structure and composition. Gaia's ability to detect faint, slow-moving objects like brown dwarfs is a testament to the power of modern astronomical technology. However, this discovery also underscores the need for future missions that can explore the outer reaches of the solar system in even greater detail. NASA's upcoming Nancy Grace Roman Space Telescope, scheduled for launch in the late 2020s, will be able to survey wide areas of the sky in infrared light, making it an ideal tool for discovering additional nearby objects that have thus far escaped detection. What comes next? The discovery of a star closer to Earth than Voyager 1 marks a watershed moment in astronomy. It raises tantalizing questions about the boundaries of our solar system, the presence of other unknown objects in the neighborhood, and the nature of brown dwarfs. Future studies will undoubtedly focus on characterizing Gaia DR 4042321 in greater detail, determining its exact mass, temperature, and composition. Astronomers will also be keen to search for other nearby objects, potentially uncovering a hidden population of stars and brown dwarfs within the Oort cloud or even closer to the Sun. As we move forward, this discovery serves as a reminder that even after decades of space exploration, there is still much we do not know about our own cosmic backyard. The universe is full of surprises, and as our technological capabilities grow, so too will our understanding of the mysterious objects that inhabit the outer reaches of the solar system. In the meantime, Voyager 1 and 2 continue their lonely journeys into interstellar space, still transmitting data from the edge of the solar system. These spacecraft, along with new discoveries like Gaia DR 4042321, remind us that the exploration of the universe is a never-ending adventure, full of unexpected twists and revelations. And with every new finding, we take another step closer to understanding our place in the cosmos.